You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. All right, here in the land of British Columbia, Vancouver, Canada, here with Huamin Chen. Hi, Huamin, how are you?
Alex, I'm doing very well. This is a great time to meet you.
So nice to have you on our show.
Oh, it's my pleasure.
And we're going to be talking about the 5 steps to deploy cloud-native, sustainable foundation AI models.
Yes. So as we all know, we get a lot of excitement from ChatGPT and all these foundation models in the news. But we have not got to know is that why should we take care of these models in deeper technology hands. So this talk is to bring us some of the impacts and to see what we can do to help the world get more and more sustainable using these foundation models. Hopefully that will also get more community involvement inside to help us.
I'm looking forward to exploring that. So let's talk about the first step.
The first step is to make the foundation model containerized. So as we know, most of the people who are working on machine learning, they're using a lot of tools, frameworks, and their own systems. They're using PyTorch for programming. They're using Jupyter Notebooks for debugging and evaluation. But very often, people running these foundation models have to put them in the production system. That's where the containerization will help. So our first step, we're actually using the community-based Docker files to containerize these workloads so that they can be deployed on cloud-native environments. That's step number 1.
So containerization is step number 1.
Yeah.
Okay. Step number 2.
So we're going to deploy them. So containers makes things possible. So to run the foundation models. And how do we run it? We run it on Kubernetes. So that's where the deployments will happen. They sound easy, but you have to take care of the little differences, such like what's the resources you should give to a container so that they will run with efficiency. So that is what we are going to talk about in this second step.
Okay. Step number 3.
So we are going to take some measurements. Run it is a good thing, but to see what is happening is more powerful. So we are going to see what is happening inside of containers, and in our specific case, we want to see how much energy used by the foundation model.
Okay, and step number 4.
That's the analytics will come in. So seeing what is happening and correlates with what the application, the AI model, and in conjunction with the measurements we get, we do analytics. And this analytics will tell us a different story.
And step number 5?
Then we use this analytics to do actions. What kind of actions it will tell us? It may be the optimization that we can use. We can optimize the energy consumption, but do some tunings, whether that is on a workload level, on hardware level. That is based on analytics feedback. With that in mind, we can help our foundation models run more efficiently and with less energy.
Okay, let's go back to step number 1. And you talked about containerization and getting the community involved. Why containerization?
Yes, that is very good point. So container is one of those founding milestones of the cloud-native applications. So once we put in the containers, applications can be portable across the board, whether you are running on your laptop, on data centers, or just in public clouds. So this makes things really easy to deploy. So that's why we said containerization is the foundation for lots of things.
Is there a need for more community involvement?
Okay, let's go. So whenever we're using some workloads for containers, we're always looking for community inputs. So in this case, we want to advocate the community initiatives behind all this containerization process. We see the foundation models, for example, in our example, we are using Bloom. This is a language model. We also use a stable diffusion. This is an image to text to image model. So these 2 popular models, once they are containerized, then they can be deployed as microservices. There could be many other models. The Facebook, the Meta, released the Llama model. That could also be containerized. So as long as we are able to containerize all the popular models, then the next level of deployments will be much easier.
And there's lots of things that engineers can do that they have knowledge about, such as maintaining the code, as we heard in a keynote today.
That's right. Maintaining the code is a hard thing because oftentimes the developers and users may not in sync, but container could be that bridge. Containers will make the developers' products handle the products right into the end users by giving them the containers. So this is one of the simplistic steps to make things happen.
And principle number 2 is Kubernetes, correct?
That's right. So Kubernetes is one of the pillar projects in the cloud-native computing environments. This is a huge success, makes things happen across the large clusters. If you have your own personal computer, you can run Kubernetes inside for experimentation. If you have very large production cluster with hundreds of thousands of compute nodes, you can run the same configuration you have without having any surprise. So that's why we said make it run on Kubernetes and make it available to the end users.
And Kubernetes is by default the distribution mechanism for containers, and so it makes sense.
Yes.
What projects are there that people might explore when thinking about foundation models, AI, and Kubernetes?
So there are a number of initiatives in the Kubernetes ecosystem. One of these projects called Kubeflow. That is specifically for the AI and AI training and inference to be in a single flow. That was one of these things that we can explore. Or if you are developing out of your own environments, this could be the container could just deploy the foundation models in simple deployments. That could come very handy. You get your containers, you get your models, you run it. So that is one of these quick ways to have the quick feedbacks from the developer, from the communities.
And Kubeflow allows for a series of tasks, correct?
Yes. You have these pipelines, you have these loops, you have the whole from the developer to end user to production cycles in this same framework. That provides a lot of benefits for enterprise.
There are other task-oriented environments such as Apache Airflow. Would that apply too?
Airflow is actually the different projects. In my opinion, it could be related to Kubeflow is doing, but it really solves the problem of data management.
Okay, so we can put that aside a little bit. So then on the third point is measurement, correct?
Yes. So we have different ways to measure the container.
Why? So I have it. Why measurement? What is the relativity of cloud-native technology measurement and foundation models?
Okay, so we are using the Prometheus. Prometheus is one of these projects that a cloud-native environment community has been using all the time. The idea is that applications or infrastructures will create metrics. And the metrics will be created in the same format as Prometheus can understand. So by Prometheus, you can scrape these metrics and have the unified dashboard and a query system to get all these end results. And that's the platform we do the analytics.
Excellent. So that provides a measurement mechanism. So again, developers might get involved in the Prometheus project to work on a sub-project related to foundation models?
That's right. They can make that happen as well. So if they are using Prometheus for some other things, for example, if they manage the infrastructure also using Prometheus, that's the place they can correlate the workloads in foundation models as well as the runtime environments in the system. So you can do a lot of correlations in that way.
The fourth step is analytics.
Right.
And so tell me how engineers might use analytics following this step-by-step guide that we're going through.
Yeah, so one of the ways engineers, as always, they can create their own analytics. But we feel that we give them some guidelines and some heuristics, they can build upon these things, they can achieve bigger impacts. So the way we do is that we provide some of the simplistic queries into Prometheus, get the basic metrics in place, and using that for our benchmark, and using that benchmark to tell us what are the, for example, energy usage from your foundation model, and how would that correlate with your performance metrics.
Because the energy usage relates to the performance of the model itself and the latency I'd expect as well.
Right. Heuristic is that the more energy you use, the better performance you get. That's the heuristics. That intuition may not always work. And
Right.
our discovery is that you can get the same performance without using more energy. So that is going to be what's going to present this afternoon as our talk.
How you can get more energy and make it more efficient?
Yeah, you are using about the same energy. So you can be very high performing the same way without using more energy.
That's a new dynamic, isn't it?
That's right.
And the fifth is then where I think people think that you can just get to with skipping the 5 steps, and that's understanding the analytics.
Yeah, this is really a dependence on each other. So once you have step 1, step 2, step 3, you can get to the number 5. The number 5 is what we believe is most important for the community, for the society, for the environment. Once we are able to optimize the energy profiles for foundation models, then the more energy we can save, the better environments we are going to get in the future.
So how have you used these 5 steps?
That is our principles of software development and evaluation process. So as an engineer myself, I do always, whenever I get something done, I always make it available as a product, as a containers. And then we should be able to use the rest of the steps to help the community to grow on their own interest.
So what then is the kind of connection for you to connect these 5 steps to these LLMs?
So that's why we want to share with the community that by using the same process, same principle, people who are working on AI, on the foundation models, the large language models, hopefully can also deploy this system in the same way and evaluate how they can improve the environments by using less energy.
Okay. And so when you're thinking about AI foundation models, then what are the different foundation models that you might recommend people to look at? Open source projects, for instance, that are LLM models.
Yeah, so LLM has a lot of potentials. People are using it in many other places. So for example, this is not my example, but if you are using it in the medical field, people have conversations with the doctors. That is some of the things that the foundation model can help you a lot. But if you have too many conversations, that means a lot of power, the energy is going to be used. How can we have the benefits of delivering the medical conversation without using a lot of energy? So that's going to be a very interesting topic for many of the end users.
I'm going to ask you for another 5 then.
Okay.
What are the 5, if you could think of 5 ways that a developer could get involved with helping, optimize LLMs to help optimize foundation AI models? We talked about some of them, but are there some others that we can discuss that might be helpful to people?
Yeah, so oftentimes the engineers and the people who do the analytics of energy sustainability are 2 different people. So if engineers and the people who are working on energy consumption working together to share the same profile on how much energy used by their models and why the engineers and AI developers can optimize their models to save more energy, then that's going to be a huge win for every one of us. And oftentimes we hear that just like yesterday, Google announced in their Google I/O meeting, they have a series of models running from small to big environments. If we can get more ideas about their energy consumption and also their performance impacts, that will help a lot of people to identify the right model to use in the right environments without losing power, without sacrifice their performance.
Energy seems to be such a big matter here. Won't that become less of an issue for developers as they start using open networks that are meant for AI development?
This could be one of the approach, but the core of this problem is that we need to have measurements in place. We need to know inside and out, so we can do certain things to optimize.
And the measurements need to be visualized in some way, don't they?
Yeah, seeing is believing.
Yeah.
Yes.
So is that a Grafana capability? Is it
That is a Grafana.
Yeah. Okay.
So when you see the dashboards, how much energy you used, we have the Grafana dashboards in our talk as well.
So I almost see a stack emerging, really not a stack necessarily, but kind of a collection of tools that can be applied here. Like in the initial stages, maybe there's software, code code maintenance tools that people could use, for instance, to help with PyTorch. People use those tools every day, right?
Yeah.
You know,
and we move on the stack. You see more and more integration will happen.
Yeah. And then in the second point is Kubernetes. They can use projects like Kubeflow, right? You know, then when it comes to measurement, they can maybe work on Prometheus, for example.
Yes.
You know, in the analytics capability, maybe Grafana, right, for the visualization.
Yes.
And then in that fifth one, then it's the results. And like, I don't know how those results are outputted. What are the...
So that's also the auto-scaling will come in. So Kubernetes have these different auto-scalers, horizontally scaling or just vertically scaling. So that's what we can do in terms of scaling and energy conservation.
And that's when they can be applied to the tools for those energy kind of usage and such, so you can keep the cost optimized, because you're going to want to get the value out of the AI model, but the value is lost when you're dissipating energy at some scale.
Yes. So I think this is the core of this problem, how we can solve the problem. These are the technology tools we use, and these are our approaches. So that's will come back to the ecosystem, to the stack, to optimize this own problem.
Well, man, thank you so much. I've really enjoyed this. It's been so much fun to hear from you about these things. It's so fascinating. I appreciate your time.
We hopefully can make you amazed and see what is coming up next.
Excellent.
Thank you.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.